Hello, my dear student. Today I am going to discuss about Edexcel IGCSE Certificate in Physics, Unit 1, Chapter 5, The Turning Effect of Forces. I am Jahangir here. I am a physics teacher.
Physics is my
My contact
business.
number is 01717979515. Edexcel specification for this chapter. First, we have to learn about definition of moments. What is moments? We know a force can cause many things to move or stop. That means a force has a ability to change its state of motion or direction of motion or shape and size. There is another role of force. When a force causes an object to turn, this turning effect is called moments. Example, a person sitting on a seesaw can turn the object. Moments of a force, also known as turning effect of force. The moment of a force about any pivot, any point, is defined as moment equal to force into perpendicular distance from the pivot. So moment equal to F into D. Unit Newton meter. Moment either clockwise or anti-clockwise. Here, look at the diagram. Force F exerting an anti-clockwise moment through the spanner on the nut. Moment of a force. For example, imagine pushing a door open. You push on the door handle and the door rotates around its hinge. The hinges are a pivot. You exerted a force that caused the door to rotate. The rotation was the result of the moment of your pushing force. So moment factor. The moment of a force is bigger if the force is bigger. The moment of a force is bigger if it acts further from the pivot. The moment of a force is greatest if it acts at 90 degree or perpendicular to the object it acts. So, moment of a force is the moment of a force, also known as turning effect of force. Turning force happens when a force is applied to the something which has a pivot. Pivot means a rotation point. The moment of a force with respect to a line perpendicular to a plane containing the force is, so moment equal to force into perpendicular distance. Moments in daily life. We make use of moments of forces in many areas of our daily lives. When we use a broom to sweep the floor, one of our hands acts as a pivot, while other hand applies a force to produce a moment. Using moment to sweep the floor. So moment make easier our life. Moments in a daily life be when we use a fishing rod. The end of the rod that pushes against our body acts as a pivot, while other hand applies a force to produce a moment to lift the catch. When we use a wheelbarrow, The axis of the wheel acts as a pivot while our hands apply a force to produce a moment to lift the load. Look at the spanner, look at the scissor. So when forces are used to open door, steer, pedal bicycle, or turn a tap, they are causing turning. The effect that a force has in turning an object rounds depends on the size of the force, perpendicular distance from the force line, and the pivot. That means the axis of rotation. Man-made devices that depend upon the moments of the forces. Here, hammer, scissors, spanner, levers, wheelbarrow, steering wheel, car steering wheel. Look at the question here. Calculate the moment exerted with the claw hammer if the person exerts a force of 80 Newton and distance d equals 25 centimeter. So moment equal to force into perpendicular distance from the pivot. Here perpendicular distance from the pivot distance is about 25 centimeter. 25 centimeter. So 80 into 25 centimeter, 80 Newton into 25 centimeter. We have to convert this 25 centimeter into meter dividing by 100. So 0.25 meter. So 80 Newton into 0.25 meter. So 20 Newton meter. The direction we know moment is a vector quantity. So it has a direction. So the direction of this moment is 20 Newton meter clockwise because this force produces a clockwise rotation, so that's why it is clockwise. Now complete the table. Here force and distance, force 40 Newton and distance 3 meter are given. So we have to find out the moment. Moment equals to product of force and distance, perpendicular distance from the pivot. So 40 into 3, so 120 Newton meter. 120 Newton meter. Then here force 200 Newton and moment is 1000 Newton meter. So we have to find out the distance. So we know moment equal to force into perpendicular distance. Here we have to find out the distance. So moment divided by force. Moment divided by force. Here moment is and force is 200. So 5 meter. Here answer is 5 meter. Now third one. Here distance and moment are given. So we have to find out the force. So force equal to moment divided by distance, perpendicular distance. So here moment 200 and distance 4. So 50 Newton. In fourth one, here distance is in centimeter. So we have to convert the centimeter by dividing 100. So 0.2 meter. So now we have to find out the moment. So 3000 force into perpendicular distance 0.2. So 600 meter. 600 Newton meter. Now choose appropriate words to fill in the gaps below. The moment of a force is another name for the turning effect of force. The moment of a force equal to force multiplied by the perpendicular distance between the line of action of force and turning point. Turning effect is measured in Newton meter. Moment can be either clockwise or anti-clockwise. Center of mass. The center of mass of a body is a point where whole mass of a body may be assumed to be concentrated. So, definition of center of mass. The center of mass is a point that represents the average location for the total mass of a system. The center of mass will remain constant during a collision. Center of gravity. Center of gravity of a body is that point at which the weight of a body considered to act. Center of gravity of a symmetrical body is along the axis of symmetry. So this is the position of the center of mass of some regular shape object. Center of mass, center of gravity is also sometimes called center of mass. So center of gravity. Center of gravity can be defined as the point in a body or system around which its mass or weight is eventually distributed or balanced, or through which the force of gravity acts. Center of mass is the point in a body at which the center of mass, entire mass, may be assumed to be concentrated. For our purposes, they are the same thing. If suspended, a body will come to rest with its center of gravity directly below the point of suspension. Finding the center of gravity of a card or lamina or any object. Fix the card at least two places. Suspend the card from one of these holes. Hang a plumb line from the point of suspension. Using the plumb line as a reference, draw a vertical line on the card. Repeat for the other holes. The center of gravity is where the lines cross the card. To find the center of gravity, so this is the process, same thing. Stability. So a body is stable as long as its center of gravity remains vertically above its base. If this is not the case, the body will topple. What factors make a modern racing car as stable as possible? One, wide wheelbase. So wide base is necessary to make an object stable. Number two, a low center of gravity. So a stable object must have a low center of gravity. Condition for equilibrium. If an object is in equilibrium, the forces on it must balance as well as their turning effect of force. That means moment. So the sum of the forces in one direction must equal to the sum of the forces in the opposite direction. The principle of moment must apply. So total clockwise moment is equal to the total anti-clockwise moment. So for an equilibrium object or balanced object, total clockwise moment is equal to the total anti-clockwise moment. Principle of moment. So when an object is not turning, that means balanced, the total clockwise moment is equal to the total anti-clockwise moment. Here, look at the object. There is a pivot. If the ruler above is balanced, then clockwise moment is equal to the anti-clockwise moment. So here clockwise moment is W2 into perpendicular distance from the pivot D2, and anti-clockwise moment W1 into perpendicular distance from the pivot to line of the action of the force D1. Look at the question number 1. On a seesaw, Mary, weight 600 Newton, balances John, weight 200 Newton, when she sits 1.5 meter away from the pivot. How far from the pivot is John? Applying the principle of moment, Mary's weight into distance equal to John's weight into distance. So 600 Newton into distance 1.5 equal to John weight 200 Newton into John distance. So can calculate distance of the John from the pivot easily by calculating 900 divided by 200, that means 4.5 meter from the pivot. Now question number 2, we have to find out the weight of the beam W naught. Weight of the beam acts at the middle of the uniform beam, that means middle of the uniform beam. We have to find out the W naught. Applying the principle of moment, so weight of the beam produces a clockwise moment about a pivot, and known weight W1 produces an anti-clockwise moment. So W1 into D1 equal to W0 into D0. So here W1 is 6 Newton and perpendicular distance 12 centimeter, and weight of the beam into perpendicular distance from the pivot to midpoint, where weight of the beam acts is 36 centimeter. So W naught equals to 72 divided by 36. So 2 Newton is the weight of the beam. Now write the apply the principle of moment for this case. So there are two clockwise moment about the pivot and one anti-clockwise moment about the pivot. So write this one. So clockwise, first write the clockwise moment. Clockwise moment here, F2 force into perpendicular distance D2 plus F3 into D3 equal to F1 into D1. This is the principle of moment for this case. So total clockwise moment is equal to the total anti-clockwise moment here. Complete for a balanced ruler. Try yourself. This is the HW for you. Try to solve this table using principle of moment. I will answer your answer. I will check your answer. If you write in the comment section. Okay, now let's try fill in the blanks. Choose appropriate words to fill in the gaps below. The turning effect of a force is called the moment of a force. Moment is measured in Newton meter. If a body is balanced, the total clockwise moment is equal to the total anti-clockwise moment. The body will be stable if its center of gravity lies vertically above the base of the body. A tractor has a large wheelbase to reduce the possibility of its toppling. Hello, my dear student. Let's start a IGCSE O level exam oriented question. It is an Excel question. Question: the diagram shows how a mechanic applies a force on a spanner to produce to undo a bolt. State the equation linking moment, force, and perpendicular distance from the pivot. Here we know moment equal to force into perpendicular distance from the pivot. So remember, moment equal to force into perpendicular distance from the line of action of the force to the pivot. Calculate the force required to produce the moment. Here moment equal to force into perpendicular distance. We have to find out the force. Here moment equals to 4.8 Newton meter, and we have to find out the force. But problem is, what is the perpendicular distance? Look at the diagram. Force acts vertically upward. So perpendicular distance means the line of action of the to the is 90-degree angle. That means 40 centimeter. Here it is, perpendicular distance is 40 centimeter. But we have to find out, convert this centimeter into meter. So 4.8 Newton meter equal to force into 40 divided by 100, so meter. Now we have to find out the force. So force equal to 4.8 Newton meter divided by 0.4 meter. So calculate this one. Here 4.8 divided by 0.4 equal to 12 Newton. So force equal to 12 Newton. Now the mechanic is not able to undo the bolt because a moment of 9.6 Newton meter is needed. Explain how the mechanic could produce a moment of 9.6 Newton meter. So mechanic is not able to undo the bolt because a moment of 9.6 Newton meter is needed. So explain how the mechanic could produce a moment. So moment depends on two things. Number one, force, amount of force, and perpendicular distance from the pivot to line of action of the force. So we can see the mark scheme. So use a longer. So mechanic can produce greater moment by using a longer spanner. Apply a force a greater distance from the pivot, or apply a larger force, because we know moment equal to force into perpendicular distance. Force into perpendicular distance. Remember, perpendicular distance from the pivot. So if the mechanic uses a longer spanner, then he or she can produce a greater moment or apply a force greater distance from the pivot, or apply, so distance needs to be greater, okay, or applying a force at right angle to the spanner. So right angle to the spanner, so applying a force at the right angle to the spanner. Thanks for watching. Do remember to like, comment and share this video, and if you have not subscribed to my channel already, go hit the subscribe button.